definitely do. Okay, so tangent. Recall. We first introduced the tangent of an angle in topic 3.2. We defined the tangent of an angle as the slope of the terminal ray, or as the ratio of the angle's sine to its cosine value. So newsflash, tangent theta is sine over cosine.
Oh, wow.
In short, tangent theta is y over x. Y over x. Okay? And it says, as we did previously with sine and cosine, we can use this understanding to develop its graph. So let's look at the slope of the terminal ray as our angle theta increases from 0 to pi over 2. So check out this angle. What's happening? What's happening to the slope of this line? The slope of this line to this line to this line to this line. It's getting what? It's increasing, getting more steep, right? Until all of a sudden it's vertical. Where? At pi over 2. So we could say that at pi over 2, when the terminal ray is now vertical, the slope of a vertical line is undefined. Slope of a vertical line is undefined. Well, that's kind of cool. Because what that means is when the slope is undefined, there's an asymptote on the tangent function. So that corresponds, okay? If you go the other way, if you go from pi over 2 down to pi, can you tell that these lines are really, really, really negative? All the way to flat 0? They go from negative infinity to 0. Can you tell that? Okay, all right, let's turn over. Which kind of leads us straight into the graph of the tangent function. We can skip that top part. I think we understand. Can you see how that's working? Mm-hmm. As we approach pi over 2, we see an asymptote. Well, remember that tangent is sine over cosine. What can we not do when we're dividing? Can't divide by 0. So tangent x is sine x over cosine x. We're going to have an asymptote every time cosine is 0. At like pi over 2 and 3 pi over 2. And if you were going around that unit circle backwards, at negative pi over 2, which is this one. And negative 3 pi over 2, which is this one. Okay? So each time the terminal ray is vertical, or cosine equals 0, the slopes are undefined. When we graph the tangent function, this means we will see vertical asymptotes with a P in there, when theta is pi over 2 or theta is 3 pi over 2. Each half turn around the circle will create another vertical asymptote. Which leads us to another important thought. It only takes a half turn before we hit an asymptote. So say it louder, Grace. Period is pi. It only takes a half turn to complete a cycle. So the period for tangent is pi over b instead of 2 pi over b. Mm-hmm. Mm-hmm. Period's positive. It's a time. Time for cycle. Yeah. Period is pi over b instead of 2 pi. Okay? You could still see a vertical dilation A. You could see it reflected. So what does that look like? That means instead of rising from left to right, it would be decreasing. Okay? You could still see a phase shift. What you're looking for is where's the origin. It's supposed to go up through 0, 0. So the next time it goes up through 0, 0, there's your phase shift. And then D, amplitude, it's supposed to be on the x-axis. Parent function or identity toolkit function, it's on the x-axis. Anything shifted above or below that would implicate that your midline has changed. Okay, moving on. Okay, so example 1 says a portion of f is shown above. The function f can be written as f of x equals a tangent of bx plus d, where a, b, and d are constants. Find the values of a, b, and d.
D is 0.
A is harder to tell. Let's start with b. Or d. You said what? D is 0?
Yeah.
Okay, because it's not shifted up or down. Let's go there. D equals 0.
You said B is not the period, right?
B is not the period. The period of tangent is pi over b. So look at the period here. How long does it take to complete a cycle? Pi over 2. How do you know that? Because you could subtract pi over 4 minus negative pi over 4, which means I end up with 2 pi over 4 or pi over 2. Any questions on how we just got the period? I can take the furthest it goes to the right minus the furthest it goes to the left and find the distance between them. So period is actually pi over 2.
So B is 2.
Which is equal to pi over b. Well, consequently, b is 2. You could cross multiply that and check it. You could have pi b equals 2 pi. Divide by pi in both places. B is 2. D is 0. B is 2. It has not been shifted off of the origin, right? This point right here. So there's no C value. But let's get into A a little bit. Here's how you figure out what A is. Go back to this function right here. This is the identity function, the toolkit function. What I know, or in Algebra 2 this year, we're calling them parent functions. We're calling them toolkit functions. It's kind of interesting. So parent function, without transformation, this is what should happen. Tangent of pi over 4, good eye, Truett. Tangent of pi over 4 is 1. Right? That's a true statement. We know that because that's where sine and cosine are equal. What do they both equal at pi over 4? Square root 2 over 2. So if I divide the same on top and bottom, I get 1. That's why tangent of pi over 4 is 1. Well, if we look at this function, it's at pi over 8 where I get 1. Halfway between 0 and pi over 4. Can you understand that? So I said this. I did f of pi over 8 is equal to amplitude times tangent of 2x plus 0. I used b as 2. And I worked backwards here to find amplitude. Well, what is f of pi over 8? 1. So 1 is equal to amplitude times tangent of 2x.
Divide by
Well, what's x? What's x supposed to be? 1 is equal to tangent of pi over 4. You see what I'm saying? So if I go in here and I say 1 is equal to a times tangent of 2 times pi over 8. This is f of pi over 8 equals 1. So I'm putting pi over 8 in place of x and setting that equal to 1. What's 2 times pi over 8? 1 is equal to a times tangent of pi over 4. So if that's a true statement, what does a have to be?
0.
A, not 0, 1. A must be 1. You want to back that out again? Try that again. We don't like that? Okay, let's back it out. Let's try that again. I really think you can understand exactly what I'm saying here. I really think you can. We know that this statement is true. 1 is equal to tangent of pi over 4, right? But in this particular picture, tangent of pi over 8 is 1. Okay? So what I'm saying here is 1 is equal to f of pi over 8. Well, my function here that we're working on is f of x equal to a plus tangent, or a times tangent of 2x plus 0. We said displacement is 0. It didn't go up or down. We said period is 2. So using this information, f of x equals a times tangent of 2x. What if I input pi over 8 for x? And I know that is equal to 1. That's a point I can see on the graph. 1 is equal to a times tangent of 2 times pi over 8. Yeah? So 1 is equal to a times tangent of, what is 2 times pi over 8? Pi over 4. Well, that's what it says on the parent function. So a has to be 1. It didn't change.
Yeah.
So I used the point where I can tell this is equal to 1. And I plugged in that for x and set it equal to 1, and then solved for amplitude.
So amplitude really won't be visible on the graph.
It's hard to tell. That's why I reasoned. And I said, okay, I know it's supposed to be at pi over 4 comma 1. If that relationship holds true, amplitude hasn't changed. If that relationship is not true, then I see it's gotten magnified somehow.
See, I knew amplitude was 1 because, I mean, if you look at, like, I don't think ratio is the right word, but if if pi over 4 was 1, when it wasn't, like, shrunken, then if you divide by 2, then pi over 8 would be 1.
That's what I thought.
Yeah. That's how
Because
I
b
saw
is
it.
2.
It should be half because inside.
So at pi over 4 or pi over 8, we should have a 1. Agreed.
But I guess that wouldn't help you if A had been a bigger number than you would know what it was.
I just pick a point and then solve for it.
Okay. Number 2.
Okay. Okay, so what's the function here? F of x is equal to tangent of 2x.
So on the parent function,
Yep.
so it goes through at 1, it's pi over 4.
Uh-huh.
You have that pi over 2, and it still goes through 1. Should you just tell?
If you knew the parent
Half.
function, if you knew,
Because you know
Is that
the
what
parent
you-
function is always going to go, you can tell right here, at pi over 4 it goes through 1, so the amplitude is 1. So if you have that, it still goes through 1.
But it goes through pi over 8 1.
But he's saying pi over 8 is half of pi over 4. So that's
This is what you're saying too.
Oh,
But we're
okay.
saying that had A been bigger than 1, we wouldn't have been able to find A by doing that. Because it wouldn't have stayed the same.
Good question. Really
If you
solid
were-
question.
If you were dilated more than you were.
Mhm. Okay, let's look at example 2. It says that the function h is defined by h of x equals 4 tangent of 2x plus 5. What's the period? So not what is b. You can see right here what b is. B is 2. But what's period?
Pi.
Pi over 2.
Oh, I thought it was 2 pi over 2.
No, pi over b, sorry. Period is always pi over b. B is 2. So your period in this problem is pi over 2. Okay? Guys, we got to stop making the mistake of thinking, I'm looking right here and I can see the period is 2. No, it's not.
It's not.
It's not. It's not. It's not. Okay? Example 3, it says let g be the function defined by g of x equals 2 times x over 3 minus 1. Which of the following gives the vertical asymptotes to the graph of g? Okay.
So we multiplied by 3. So the first vertical asymptote would be pi.
Period.
Wait.
Yeah, find the period.
Could be 3.
The period is 3 pi. Good.
So you're
3 pi. Period is 3 pi. Why? Because b is 1/3. B is 1/3.
yeah.
Yeah. Okay.
This would be 3 pi over 2.
So period is pi over 1/3. In other words, 3 pi. I agree. Keep talking.
And 3 pi over 2. Would it not be? Because it'd be half on each side, so it'd be basically 1.5, which should be 3 pi over 2.
Here's what I knew. Okay, I'll kind of walk you through my thought process here, which take it or leave it. Sometimes you guys think a lot better than I do. I thought that this tangent of pi over 2 is undefined. Right? I want to set this argument, x over 3, equal to pi over 2. Because I know tangent of pi over 2 is undefined. So if I can set x over, or pi over 2 equal to x over 3, I can solve for x, and I'll know where this is happening.
So that's pi.
So 2x equals 3 pi. Divide by 2.
Yeah, okay.
This happens every time x is 3 pi over 2. Okay, we did know that. Except, and this one hasn't been shifted off of that.
Oh, right. So
Right?
it was shifted.
If it was shifted, you'd be in trouble. Why does this period equal 3 pi come into play? Before the next one. You have to skip 3 pi before you hit the next one. So this is going to happen every x equals 3 pi over 2, and then every 3 pi k after that. Are we understanding that? Okay. Joseph said, but we knew that. We knew x was 3 pi over 2. Yeah, we did. But I would solve for it in case. That way you can catch the shift. Yep. Yep.
Because I thought is, whenever in our parent function, when our period was pi, we had asymptotes pi over 2. Because it was split up in, it was like basically half on each side. So if our period's 3 pi, then it'd be 1.5 on each side, which would be 3 pi over 2 on each side.
Right.
I don't know, the same thing.
1.5 on each side of 3. I see what you're saying.
Yeah.
Try it out, Trevor. Go ahead and number.
Do you understand what he's saying? He's saying if you take 3 and split it, you got 1.5 on each side.
Which is 3 pi over 2.
Yeah.
That just doesn't handle the next time. That's where the 3 pi k comes in. Good question. Really good thinking today, y'all. I know we are few today, but we are on it. Oh my goodness. Truett. I just bragged on you on the YouTubes. Truett's a brilliant guy. He's also a little lazy. But we'll keep him. This one's not hard. Example 4. What?
Joseph's smarter and lazier.
Facts. Okay. What's the period here? Oh, say it louder. 2 pi. The period here is 2 pi. So what does that mean for B? If the period doubled,
A is half.
it's half. B is half. You got to think, insiders lie. If your period doubled, B is half. So eliminate what? C and D. Okay. What else can you tell from this function? Where? No, down. Down. Down how many?
2.
Down 2. Outsiders tell the... So the answer is... Okay, good. Example 5. Find the following values using expressions from the unit circle. Okay, quit looking at me like that. This is just ratios. Sine over cosine. So you got to think, what's tangent of pi over 6? Well, that's going to be sine of pi over 6, which is half, over cosine of pi over 6, which is a long 3 pi square root 3 over 2. So you can multiply by the reciprocal. They call it 1 over square root 3.
Hey, G and I are undefined.
G and I are undefined. You can have that from Joseph.
He is one. He is one.
Nikki's helping. Nikki's helping. Okay, y'all finish this. That'll be the end of the day's lesson.